Okay, so hey guys, welcome back, and today let's start again with the question of Leetcode daily challenge. Let's see what we have today, and we have here. Let's see. Fine, we have the find all the possible recipes from the given supplies. Okay, let's see what the question is. Is that you have information about n different recipes. You are given a string array recipes and a 2D string array ingredients. The ith recipe has the name recipe I, and you can create it if you have the all the needed ingredients from the ingredients I. Means ingredients जो है वो 2D array है, and index will be same like bread को बनाने के लिए yeast और flour चाहिए हमें. ठीक है. रेसिपी कैन ऑल्सो बी एन इंग्रेडिएंट फॉर अदर रेसिपी. लाइक अगर ब्रेड को बनाने के लिए यीस्ट और फ्लोर चाहिए, ये दोनों हमारे पास है, तो ब्रेड बन गया, तो ब्रेड भी एक इंग्रेडिएंट हो चुका है. अगर किसी को बनाने में ब्रेड की ज़रूरत होगी तो वी कैन मेक इट, राइट. सो अगेन, if we have this recipe bread, and what we need to make it is the ingredients yeast and flour. Okay, the same index it will have. Now if we have the yeast and flour, which we need to make the bread, then the bread will also be a one more ingredients. Like if any other recipe is there to make which bread is needed, then we have this as the ingredient, because we can make bread from this, and then we can use bread to make that recipe. That's the thing. Now you are also given a string array supplies containing all the ingredients that you initially have. Okay, we have a array supplies which will contain all the ingredients we initially have, from where we have to start, and you have an infinite supply of them. Okay, and return a list of all the recipes that you can create. You may return the answer in any order, and not that two recipes may contain each other in their ingredients. Fine. So see what the basic question is now, that let's take to this example. Okay, bread and sandwich are there, two recipes are there, ingredients array is there. So to make bread, yeast and flour are needed, and to make sandwich, bread and meat are needed. Fine. In the supplies, we initially have yeast, flour, and meat. Now see, if you see that we can make bread, obviously yeast and flour are there in the supplies. Bread can be made, but can we make sandwich? Because meat is there, but bread is not there. So first we need to make bread. Then, if we have the bread and we have meat in the supplies, now we can make sandwich also. So we can make both of these. So if you think about something, you will relate this question to something. If you have done the question course schedule in the graphs, where we have the interdependency between the courses, that to do the course A we need to do B, to do the course B we need to maybe do some C, right? And this is the same kind of question, isn't it? Right. So one thing is simple, that it relates to the graphs question, so it can be done using BFS or DFS, and I can also think about the approach of it. Maybe you should also try to think of it according to that question, if you have done that. If you haven't done that, you can try it also in there. Its name is, I guess it's course schedule, I'm not exactly sure, but yeah. If you see now, it's this question has become so easy. What's our purpose is, we need to find that recipe for which every of its ingredients is there in the supplies. Firstly, we need to find that recipe for which we have everything. For bread, we have everything, so we can make bread without any dependency. After making bread, now we have bread also in the ingredients. Now we can make sandwich. Okay, sandwich has a dependency that it needs bread, but it's not there. But bread has no dependency, so we can make bread first, then make sandwich next. So it can be done in this type. So let's try to do this using BFS, because it will be so easy using the queue. First, let's take the number of recipes we have. Okay, and for supplies, let's not make it redundant, and we will take a set here, set of string, and that will be supplies, and that will be supplies dot, initially the supplies are these. Fine. Now after that, what we need to do do next is we can do one thing. And if you remember that question course schedule, how it did it was the topological sort, using topological sort. Topological sort basically sorting them on the basis of the in degree or out degree, on the basis of degree. Okay, so let's take a vector degree, that will be integer obviously. Initially all the recipes had degree 0. Now let's calculate the degrees of the recipes. Now degree of a particular recipe means the value of degree for a recipe. What will it signify? It will signify the number of ingredients it needs to be made, but it's not present in the supplies. Means for sandwich the in degree will be 1. Why it will be just a second. Yeah, okay. So why it will be 1 is because sandwich has one ingredient which is not in the supply, that is bread. Okay, so the number of ingredients which are not in the supplies is the degree for our recipe. I can't make it more simple than that. So I guess it's all clear after that. And we will make a urgency list kind of thing, that will be an ordered map, and it will be string to vector of string, recipe to the ingredients it needs, vector of string. Perfect. Yeah, adjacency. Now let's calculate the degree for everybody. We go to each recipe. There are n recipes, so we will run this loop n times, and for each recipe we will map through its ingredients and see if those ingredients are in the supplies. So for auto, we can also take string, but let's take auto s of ingredients. I guess the spelling is correct. Ingredients, yeah, correct. Ingredients of this, what? Ingredients I. Yeah, ingredients I, because the ith recipe has uh, needed ingredients I. Okay, ingredients I. We will loop through this, and for every ingredient we will check that if it is contained in the supplies or not. So if it is not in the supplies, how will we check is the count of it in the supplies set. Okay, if this ingredient is not in the supplies, then we will add it to the adjacency list. Then we will add that index in the adjacency list of this ingredient, that for this ingredient S is needed in which recipe, ith recipe, but it's not there. This is what adjacency list means here. And we will obviously increase the degree of that I. We will increase the degree of this particular recipe, that one ingredient is there which is not in the supplies. Okay, now there needs to be a recipe for the question to be solved, or for something there to be an answer. There needs to be at least one recipe which has all its ingredients in the supplies at the initial time. Okay, if bread needs these two, and let's just suppose that for bread or sandwich, for both of them, not all of their ingredients are in the supplies. So what we have to make, we can make nothing out of it, right? If we take out the flour out of the supplies, we have yeast and meat. Can we make something from them? No, we cannot make bread, or we cannot make sandwich. So the question will be ended there. So we need at least one recipe which has all its ingredients in the supplies initially. Okay, so now we will check. And how will we check it, that if there is something like that or not? With degree, right? If the degree of a recipe is 0, that means that it has all its ingredients in the supplies, because then it will not be incremented for that recipe, and it will be 0 for that. If it's 0 for that, we know that all its ingredients are already in the supply and we can make it at the initial time. So for I0 to I less than n, for each recipe we will check. We'll make a queue here because we will be using BFS. q string, yeah, q of string here. Well, we can take int here because we are dealing with the indexes anyways. So in the queue, sorry, here we will check if degree of I is 0, then we will push it to the queue, push that index to the queue. And now we have something for which we can make it initially, okay? Because for that we have always, like, bread will be there, which we can make initially. So bread has a degree of 0. Okay, now simple BFS. While the queue is not empty, we will go on and let's take an answer vector. Let's take a vector which will signify the answer. Now we will go to okay, int f is q dot front. We will pop the q dot front and we will push in the answer. Yeah, answer, we will push back this particular recipe I, because it can be made, it has all its ingredients in the supplies. After that, what we will be doing is that recipe I, yeah, correct. So now we will check the adjacency list of this particular recipe. Now this recipe is made, bread is made. Now we will be adding this recipe bread to the ingredients now, to the supplies now. Now we have it in the supplies, we have bread. So if something needs bread to be made, we have the bread that can be made, okay? So we will check the adjacency list of bread. That, what does it mean? That does any recipe needs bread in its ingredients to be made? Yeah, sandwich needs bread. So we will go to this adjacency of recipe I, means bread, and we will do what is that yeah, we will decrement the degree of all of the recipes where bread is needed, because we have one more ingredients for them which was not initially there. So we will decrease their degree by 1. So, and after decreasing the degree by 1, if they become 0, we will add it to the queue. Simple as that. We will add them to the queue, and that's all we need. And we'll just return the answer. Yeah, I guess that's all. That should work just fine. Okay, there's a problem there. If yeah, not a problem. Fine. Okay, man, what the hell? Urgency S. Okay, do we need to push it back? Yeah, obviously we do. We are pushing back I integer. Okay, there needs to be int. Fine. Because we are dealing with the index of the recipes, we are not using the recipe name anywhere for anything. Recipe, not recipe, it's recipes. Perfect. Okay, here also. Oh man, it's fine. What happened here? Okay, it's F, not I. Another thing. That will be fine. Yeah, that works fine. Perfect. So yeah, that was the question. Pretty easy question if you have done these type of questions earlier, and like, we need to you see, if we need to do it the easy way, we need to relate it to something we have already done, and that will, this question becomes so easy that it can be done within 10 to 15 minutes, is because we can relate it to this graph question course schedule which we have already done. Okay, It becomes easy this way, otherwise you will have to come up with a logic. You have to simplify it in terms of some other way. You have to come up with the topological sort or Kahn's algorithm, and then you will do it. And if you have done the course schedule, the whole idea is with you, and you can just do it easily. Otherwise it will maybe you will struggle to uh, find which data structure to use, which algorithm to use. There are ways, number of ways to do this question also, but that's the easiest ways and the most optimal algorithm, I guess. The Kahn's algorithm is the name, and topological sort is the thing we need to do here. Means wherever the degree is used, it's called topological sort. So that's how we do this, and it becomes so easy to do this way. So that was the question for today, and pretty easy one. Yesterday we had a hard one, today we had a medium, but yeah, kind of a easy one if we have done the questions similar to it earlier. So that will be it for today, and we'll meet tomorrow again.